And we are now ready to start Chapter 8. So Chapter 8 is a trigonometry chapter, and I think it'll be really fun. So we're going to start out with some right triangle trig review. So this is stuff that should be familiar with you. If you remember, trigonometry is relating to always a right triangle. So we're going to start with the right triangle, and it's a quick review. We're going to notice where the right angle is in the triangle, and know that remember there are two legs and a hypotenuse. The hypotenuse is always the longest side. It's always the side that's opposite the right angle. And one leg we call the adjacent because we're in reference to one of the acute angles of the right triangle, and we call that theta. So we always notice which reference angle we're looking at. Right now the angle theta is right here, so this leg is the adjacent leg because it's the one that's right next to, and it makes up the theta angle. This one would be the opposite because it is opposite the side of the triangle. So if we're looking at sine, the sine of theta, the ratio of that relationship is the opposite side over the hypotenuse. Cosine of theta is the adjacent side over the hypotenuse, and the tangent of theta is the opposite over the adjacent. If you remember, we had a little saying that helped us remember this, and it was SOHCAHTOA, and you could think of it like this: SOHCAHTOA. And that is the three trig relationships. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then we have three more that are the inverses or the reciprocals of these relationships that are also quite commonly used. So we need to be familiar with them. So a cosecant of theta is the inverse of the sine of theta. We just flip the fraction around. So it's the hypotenuse over the opposite side. The secant, we abbreviate it SEC, secant of theta is the inverse or reciprocal of the cosine of theta. It's the hypotenuse over the adjacent. And the cotangent of theta is the adjacent over the opposite. Now, how I remember that? The cotangent is easy to remember because, it's like the opposite of tangent, so cotangent. Sine of theta, you just have to remember that it's the cosecant, and I kind of remember that it has an S in the middle, and the cosine, you would think, I kind of look at it like this: cosine is COS, secant is SEC, so the S and the C are inverted. So that kind of helps me remember which one is this. You also can look at your notes and help you remember that too. So when it says to find the exact values, no decimals, that means we're going to either leave it as a fraction, we don't have to change it to a decimal value, or we're going to have some whole number. So when we look at this, theta, we're looking at, there's basically two main triangles that we use that are common. One is the 30, 60, 90 triangle, and the other one is the 45, 45, 90 triangle. And those are the most common ones. We use those a lot. And so, let's get familiar with how these work. So as a quick review, the 30, 60, 90 triangle, the two legs are different lengths. So that's one way to remember that these are the different lengths here. And the short leg is always half of the hypotenuse. That's just how that works. It always is. So if the hypotenuse is 2 units long, the short leg is 1 unit long. And the short leg is always opposite the 30-degree angle. So, if you think about it, that angle is smaller, and so it's going to project over here and make a smaller side. So that's the short side. Short side is 1, hypotenuse would be 2. And if that's the case, then the long side is exactly square roots of 3 times bigger than the short side. So everything is in relationship to the short side. We kind of find that first, and that's going to help us find the other 2 sides. So 3 different values. You know, if you know the tangent, you're looking for the short side, we cut it in half. If you know the long side and you want to find the short side, you divide it by the square root of 3 to find that. So the reference point is always the short side. As a quick review on the 45-45 triangle, the 2 legs are going to be the same length because the 2 acute angles are the same. And the hypotenuse is always going to be square roots of 2 times bigger than either side of the leg. So if you know the hypotenuse, you would divide by the square root of 2 to find the leg. If you know the leg, you multiply by square roots of 2 to find the hypotenuse. So let's fill out this table here to show the different proportions and relationships here. So first we're going to start with the sine of theta. And if you remember, the sine is opposite over hypotenuse. So when we look at this angle right here, and it's always a good idea to like put your finger on the angle that you're looking at or circle it or something, so you're like, okay, now I know which one's the adjacent angle, be the one right next to it, and now I know which one's the opposite angle. The hypotenuse is always the hypotenuse. So sine, we are looking for the opposite over the hypotenuse. So that would be 1 over 2, or 1/2. I'm just going to continue on with the cosine of the 30-degree angle. So the cosine of theta, cosine is adjacent over hypotenuse. So it would be the square root of 3 over 2. The tangent is the opposite over the adjacent, so it would be 1 over the square root of 3. Now the cosecant, if you remember, it is the inverse of the sine. So I could look at the angle and go, okay, sine would have been opposite over hypotenuse, so instead I'm going hypotenuse over opposite, 2 over 1. Or you could just look at the sine and take the reciprocal of that number, which that's usually easier to do. The secant is the reciprocal of the cosine, so that would be 2 over the square roots of 3. Now, let's finish with the cotangent. Cotangent is the inverse of the tangent, so that would be just the square root of 3 over 1, or just square roots of 3. Now, one thing to notice on here, if you remember, this value right here, 1 over the square root of 3, that's not a simplified answer, and we can't leave our answer as that. So we would then have to multiply top and bottom by the square root of 3, so hopefully you remember how to, this is called rationalizing the denominator, so we want to get rid of this irrational number out of the denominator. So when we do that, we end up with the square root of 3 over 3, because the square root of 3 times 3, square root of 3 is 3. So then we can just leave our answer as that. Same thing with this one here. We're going to multiply the square root of 3 by the top and square root of 3 bottom. So we get, I can squeeze it in here, I get 2 square roots of 3 over 3 for the secant. Okay, now let's look at the 45 angle. So again, I'm going to circle the 45 just so I can remember that's the reference angle I'm looking at. On this one it doesn't really matter, but it's just a good habit to get into, is to circle it or put your finger on it or something. So the sine is opposite over hypotenuse, so that would be 1 over the square roots of 2. And I'm going to go ahead and rationalize that denominator, get rid of the square root of 2, square root of 2, and so we end up with the square roots of 2 over 2. Again, I apologize for the handwriting here. I'm not really talented with using a mouse to write with. So hopefully you can read that. The cosine is the adjacent over the hypotenuse. And notice that's going to be the same value. So I'm just going to go with the simplified version, square roots of 2 over 2. The tangent is the opposite over the adjacent, which was just 1 over 1, or just 1. And now the cosecant is the opposite of this, so it's square roots of 2 over 1, or just square roots of 2. The opposite of the secant is the same thing. And, notice here on the 45, the sine and the cosine are the same because the legs are the same, so it doesn't matter if you're using opposite or adjacent. So then the cosecant and the secant will be the same. The cotangent will be the reciprocal of 1, which is 1 over 1, so still just going to be 1. Now looking at the 60-degree angle, so our reference angle is 60 degrees. So I'm going to circle it in red because that's the color I'm going to use now. So the sine is opposite over hypotenuse, which is the square roots of 3 over 2. The cosine is the adjacent over the hypotenuse, so that's just 1/2. The tangent is the opposite over the adjacent, so square roots of 3 over 1, or just square roots of 3. Cosecant is the inverse of this, which is 2 over square roots of 3, but again, that's not a rational number in our denominator, so I have to multiply by the square roots of 3. So I get 2 square roots of 3 over 3. And the secant is the reciprocal of 2 over 1, which is just 2. The cotangent is 1 over the square roots of 3. So when I multiply top and bottom by the square root of 3, I would end up with the square root of 3 over 3. Some problems that we would have to look at with this would be, for example, looking to see is the cosecant of theta equal to 1 over the sine of theta, or in other words, the reciprocal of the sine of theta. So we could look at, let's look at a triangle again because we want to prove that these are either true or false. So I'm just going to call this side A, and this side B, and this side C. So the cosecant of theta, if you remember, it is the hypotenuse, and I'm going to call this angle right here theta. So it's the hypotenuse over the adjacent, which would be C over A. And the sine of theta would be, well, I'm going to go 1 over, the sine of theta would be A over C, and so 1 over A over C is equal to C over A, so this one is true. Secant of theta, the secant is the hypotenuse. I'm going to look back at my picture over here. The hypotenuse over the adjacent, so C over B. And 1 over the cosine would be B over C, so 1 over B over C, which if you take the reciprocal of that one, it is the same thing. And third one, the cotangent. Cotangent is adjacent over opposite, so that would be B over A. And then 1 over, the tangent would be 1 over A over B, which if you take the reciprocal of that, that one is also true. Now this one's interesting. Let's again draw a picture because we're going to reference our picture. I'm going to call this angle theta. It just has to be one of the acute angles. And I'm going to call these A, B, and C again. So the sine of theta, let's take the sine of theta. So here's theta. Sine is opposite over hypotenuse. So that is A over C. Now if I look at this 90 minus theta, well if I take 90 degrees and I minus this angle right here, I basically end up with this angle over here.